Well, good afternoon, ladies and gentlemen, and thanks for joining us today for this inaugural session of Data Science series of masterclasses presented by HP India, HP Inc. India. Today, we're going to talk about unlocking business value from data. I am Anil Chopra, VP Research and Consulting at Cyber Media Research, and your host for the day. Now, we have a very interesting and exciting lineup of sessions for you today on a hot and emerging area, which I just mentioned, data science. Which I'm sure most of you must be curious to know more about and how it can be leveraged, for your business, how it can really benefit your business. But before we start, please note that for the duration of today's session, all participants will be in listen-only mode. You can, however, keep sending us your questions through the chat window. We have a Q&A session towards the end of this webinar. But yeah, in the if time permits, we will also try to address some of the questions in between the sessions as well. And what's more, to kind of motivate you to ask lots of questions, you might, if you ask some good questions, you might be the lucky winner of an, Amazon gift voucher worth 500 rupees. So please pay attention and post those questions. So with that short note, we'll begin. And, to really briefly set the context for today's session, as we all know that, increasing levels of digitalization have caused a dramatic increase in data volumes. And organizations that can actually leverage this growing volume of data to draw business insights can have a significant competitive advantage over others. This, of course, is easier said than done because the growing volumes of data, they create so many data silos. There's so much of unstructured data that kind of comes in. So, there are challenges of integrating all these, sources of data, being able to put all the unstructured data in shape so that it can make sense, it can be analyzed. And some of the challenges involved in that and the skill sets required for the job, these are some of the questions we'll try to answer today, as well as what are some of the systems and all that you need to be able to analyze data quickly, such volumes of data quickly and efficiently. And to answer this basically is really all these questions. It's not really an art, it's a science, data science, right? It's a science to really unlock business value from data. And so to answer these questions, it's really my pleasure to invite our first speaker, Mr. Pankaj Rai, Group Chief Data and Analytics Officer of one of the largest conglomerates, Indian conglomerates, Aditya Birla Group. Welcome, Mr. Rai, and thanks for joining us today.
Thank you, Anil. Thanks for having me.
Yeah, now before I hand it over to you, Mr. Rai, I'll just spend a few minutes to give you a brief introduction to our attendees. Mr. Rai is an industry veteran with a very diverse portfolio of experiences, including consulting, credit, Six Sigma, strategy, analytics, and digital across financial services and offshoring. And he has worked with reputed organizations like Wells Fargo, Standard Chartered, Bank, GE Capital, just to name a few. As Chief Data and Analytics Officer at Aditya Birla Group, Mr. Rai is enabling the analytics maturity journey across group companies by solving problems leveraging data science. Creating horizontal data platforms, as also developing people capabilities. Welcome once again, Mr. Rai. It's really a pleasure to have you, and we'd love to hear insights on unlocking business value from data, your role at Aditya Birla Group, some of the data-related challenges that you face in the group, maybe with some examples of that our attendees could benefit from, and of course, how do you really get the right skill sets for data science? For our attendees, if you do have any questions during Mr. Rai's session, please feel free to post them in the chat window, and Mr. Rai will try to take them up during the session. Thanks once again, and with that, over to you, Mr. Rai.
Thank you, Anil. Thanks for inviting me. And in our field, or in my data analytics field, the typical way people think about it is data, which should lead to some insight, which should lead to some action. So data, insight, action seems to be the way a lot of people in our industry think about, and I will apply the same logic to our session today. So I'll share with you a lot of data, and that data will be my own personal experiences of working in different companies, what I did, what I learned in terms of data insights, so on. After sharing those experiences, and while doing it as well, I'll try to share some insights on what is it that I learned, what is it that I picked up, what is it that you can take away. And in the end, try to give some kind of an actionable for all the audience to say, how do you sort of, what is your takeaway and what could you do? So that would be my approach. So first of all, I will say that I look at data, insight, action actually in the other order, which is action inside data. And the reason I make that suggestion is that many a time, we start with data and say, what do I do with it? And I say, let's not start there. I think the best place to start is, what action do you intend to take? What decision do you want to make? And once you have a sense of what decision that you want to make, then maybe you realize what type of insight do you want. And after that, then you go and pick up the data that allows you to draw those insights. So I think in some ways it's the other way around, the way I look at it. But anyway, let me just share with you, my experience in a chronological order. So I was, in my generation, most people were given 2 or 3 choices. You become a doctor or an engineer or a chartered accountant. My dad, who was an engineer, was very risk averse, and he made sure that I studied biology and this, and took exams for both medicine and engineering. Thankfully, I got into engineering and, got away from medicine, which I did not like. And after that, I realized that actually I didn't enjoy engineering too much. So the breakaway opportunity in those days used to be, do it, then you can get away from engineering. So that's what I did. So my first job was in a consulting company called Feedback Ventures, where I was supposed to advise companies on what business should they enter. So when you have to advise people into entering a business, there also you need data. You have to do industry analysis. You have to look at the profitability, product, all that. So I would use a lot of data and insights to tell CEOs or founders or new companies coming into India on what businesses to enter, doing a lot of secondary research, primary research, talking to people, so on and so forth. So I would say data was used to make that advisory recommendation, so to say. From there on, I moved to ICICI, which was at that time a project finance company. Now it's become a large bank. And project finance required us to lend money to companies. So there again, you would look at their financials, you will analyze the company, industry, profitability, long-term nature of that business, and then again make a recommendation of how much loan to give, what type of covenants to put in, what type of interest rate to put in, so on and so forth. And then when things go wrong, then you have to again look at data to say, what do I do with it? Now they're not able to repay. How do I restructure the loan and all of that? So all of that used to happen. Then I moved on from there to G Capital, again a financing business, but more shorter term businesses. So there you had to look at slightly different types of data. Sometimes our collateral or something that they were pledging was also shares. So then you have to monitor the value of the shares. If the pledge value is going down, then you need to take action. So again, you were driving business using some data and using some analysis. From there on, I moved to Standard Chartered Bank briefly, and after that into Dell. And Dell is where I led or almost created a data analytics team. And that is when this term data analytics came into my lexicon, and probably the industry lexicon as well. Because even before that, I would say that I was using data and analysis to make recommendations, decisions, and so forth. But that's the time when I think this thing became more visible. Although in GE also, data analysis was seen as an important thing, but it wasn't such a big deal then. And so Dell was where we did a lot of these types of things. From there on, I moved to Wells Fargo. There it was more digital product teams, having new features. How do you launch those product teams? And now I'm in Aditya Birla Group, which is, as all of you know, large Indian conglomerate, which has lots of different businesses, from manufacturing, where we make aluminum and carbon black and cement, to retail businesses like the fashion business, which is the Pantaloon and Louis Philippe and some of those brands. And then we have the financial services business, which is called Aditya Birla Capital, where we do financial services products like health insurance, wealth insurance, and so forth. So it's a fairly large conglomerate where our job is to help each of those businesses and functions become more data savvy, right? So here that's what we are trying to do. So I would say that what I have seen over time is that given that this field has gained a lot of ground in terms of people talking about data, a lot of people are starting to think about data. And my own view is that we should never start thinking from the data side. We have to always start thinking from the business side, because end of the day, the goal of anything is to enhance the business, transform the business, take better decisions. So many a times when certain fields become a buzzword, there is a danger of people falling into the trap of utilizing it for the sake of it. That everyone is using data analytics, so I should do it as well, and all of that. So my theme has always remained that start from the business. Where is the business? What does the business need? And then if you need decision making and you need data for that, that is when you should do it. So how are we helping our group companies get there, utilizing some of these insights that I speak about? So what we have done over here, we are a internal, you can say a think tank / a consulting team whose job is to help all our group companies become more data savvy. So in some senses, we are here to help them develop their internal capabilities. They are doing what they are doing, but we are there to help them. So the way we have organized ourselves and the way we have started to guide them is as under. So one, we are saying, first of all, you have to have a business strategy, and we as a team who are here to help you should be aware, should be part of that business strategy. Within that business strategy, we are using a term called digital ambition, saying, okay, what is your digital ambition? How digital various parts of your business ought to be. And digital ambition is a sort of a larger Gartner framework that we use, where we have a set of questions to say, are you optimizing your business or are you transforming? And within optimizing, what are the areas and all of that? So we go through a structured process with the business to say what should be and can be and need to be digitalized, so to say. So once you have a business strategy, you develop your digital ambition, which means which are the muscles of your business which need digital flavor to make them better, efficient, transformation, so on and so forth. And then on to say, okay, now that we've figured out what we need to do from a digital perspective, 3-year roadmap and so forth and so on, how do we now deliver it? So there what we have created is a sort of a 4P model, as we call it. So we call it projects, platforms, people, and partnership. And I'll go one by one to say what it means. And that's how we have organized our team. So the project part is to say that, if you have, let's say, you're a large manufacturing company, say Ultratech Cement, you think logistics is a large part of your cost and you want to become more efficient to it. So clearly logistics optimization would be a priority, and using digital to that would be clearly a priority. So therefore, the data science team, which is the first project team, will try and go figure out how are you doing, how are you optimizing your transport routes, so on and so forth. Also, maybe we can use data science to find better ways of optimizing your transport route. So this is a project where you data science, you optimize the route. But some of these projects tend to be one time and they're not sustainable and they're not repeatable. So the second piece, which is the platform, is to say, how do I now make it part of your process? How do I make a platform out of it? Platform is nothing but a set of algorithms which are there. So you're digitalizing that whole process so that the data can keep going in, versus a one-time project, it becomes more of a platform. The benefit of a platform for a large groups like us is that you can add more features to that. So logistics is a huge field. You can do track and trace, you can do vendor scorecard, you can do so many things. So you can evolve that platform. Two, that same platform can be used by other group companies because they also have logistics and so on. So the second piece is the platform team. So the first team is the data science team, which has data science type people who do statistical modeling. The second team, the platform team, has data engineering type of people who understand the platform, who create a more automated way of doing AI, ML, MLOps and so forth. The third team, which is the people team, which is largely sort of using outside vendors, is to say, now how do I teach our managers, our individual contributors, our leaders in those businesses to understand this and use it on their own? Because the idea is not to be a service provider for them. The idea is for them to learn this and become a user of it and absorb that digital capability within themselves. So we think of ourselves as a player and then a coach. So we play using projects, we kind of create a platform, then we train you. So now we are becoming a coaching. Now you can do it. I think we made it easy for you and so on and so forth. And the last piece really partnership. And partnership is all about, we don't want to and we shouldn't do everything ourselves. So we have developed a lot of ecosystem of partners, and these partners will be, startup companies, which bring some new ideas, and we have a way to absorb them. There are large, tech companies like our Microsoft, Google, and so forth. They have done a lot of good work in this area. So we bring them on wherever they have some capabilities. The third category is what we call the industrial tech company, because we are an industrial company. So companies like ABB Digital, NG Digital, and Schneider, and Siemens, and so forth, they have their own digital practices. So they bring in a lot of capabilities from there. So we bring on those things. So the idea is to partner wherever there are industry standards available, rather than try to reinvent something on your own. So our make versus buy decisioning, because there's such a large digital roadmap. What should you make and what should you buy is a common question often asked. So the way we have thought about is that whatever is an industry standard problem, let's buy that. And then what is unique to us, let's build that. So it's basically buy and build, because mostly in every area, when you think of logistics, there's a lot of stuff which is very standard, but then there's some very unique thing that we do in our company, or there are certain things that we want to do very uniquely, because that is the source of our competitive advantage. So those are the things that we build on top of what we buy. So that's the approach that we follow in doing that. So I think the larger picture over here is that we have started on that journey with all of these different group companies. And if we look at if I can say the end game, or if there's no end game in some of these things, but if I have to say the next milestone, what would success look like for our team? The way I would look at it is that many of these companies, don't have internal capabilities of doing data science. So I would feel that 3 years from now, if all of them actually have their own data science team as well, because then what can happen is, once we have either trained their own people who can become slightly data savvy, or we have helped them hire those people and created an internal team, I think what that will do for them is that a lot of the run the business and the regular stuff here and now can be done by them. And the central team, which is our team, can then focus on the more futuristic things which they can think about. So right now what is happening in many businesses is that the businesses are not very data or digital savvy. So a lot of work that is coming our way is what I say here and now type of projects. And what can I do now to take a decision? But I think there's a lot of merit in building for the future. So today, I think we think that if we can transfer many of these capabilities that we are building for them, which is more here and now, more day-to-day tactical decision making, if that can be taken up by the businesses themselves, our teams can start to focus on more futuristic things, building, looking at future technologies. Let's say we can create a, blockchain center of capability, which we are thinking about, and how do we utilize that? What are the use cases and so on. So right now we are constrained by thinking about the future and doing experimentation. But in future, if we are able to build internal capabilities in those businesses and functions, then they can do some of those things on our own, and we can focus on the next generation things and so on and so forth. So I think what I would like to now sort of summarize in terms of what I have learned through my experiences with Dell and Wells Fargo and here and even before that is that the learning actually came through GE, where I was a Six Sigma person, and Six Sigma was all about process improvement. I think that end of the day, it's all about process improvement. And there's a methodology in Six Sigma called DMAIC, which is define, measure, analyze, improve, control. And we used to use Six Sigma methodologies to improve processes, and manufacturing companies are very familiar with that. I think that DMAIC process used to have an A in the middle, which was analyze. And I say that, because data has become too much, that A has become very critical, but the whole DMAIC philosophy hasn't gone away. So what we try to mandate to our own people is to bring that process-oriented thinking, that Six Sigma thinking, process thinking, saying, hey, you've got to know the entire process end to end. You need to know what is it that is worth improving. Defining the right problem is very critical, because many a time we don't define the problem right enough, and then we solve a superficial problem and the root cause is somewhere else. So some of that process-oriented thinking, I think, is very, very foundational. The second thing which we find very useful for our people to learn about, which is design thinking. So design thinking is all about outside in, thinking from the customer perspective and so on and so forth. So that's number two. So process orientation, outside in thinking. The third one is this whole understanding of the commercials, because many a times people are doing analysis and doing various things, but not having a ROI or a commercial orientation in mind. And that's very, very critical. So that's something that we are, making sure that our people learn about. And the fourth skill, very, very important, but sometimes neglected, is about change management, soft skill, relationship building. So therefore, our internal framework for training our people is not just about data science and data engineering, which is clearly important at the center of it, but there are these four themes that I spoke about are the surround sound, which if I can say so, that whole Six Sigma process orientation, because you're improving a process really, the outside in orientation through design thinking, the commercial orientation to understand the finances of what you're trying to do and why you are trying to do that, and this whole piece has to come together. And we talk to our people to say that, you have to be there's this term called full stack developer in technology. And we say that, you have to become a full stack employee. Unless you know all of these things, you're not a full stack person. So we try to train people irrespective of which domain they come from. They are trained on all of these skills, because at the end of the day, some of these things are all about managing change. Because whenever our people go and work with different businesses, they are used to doing things in a certain way, and you have to figure out what the problem is from their standpoint, then find a solution that they are able to use. So if you are doing something at a factory shop floor level, you need to really walk in the shoes of the floor manager in the factory, and unless you appreciate and empathize with that, you are unable to define the problem in the appropriate way, and your solution may not be usable by them. So I think all in all, I would summarize by saying that my learning and insight has been that it continues to remain focus on business, making an impact. That is where it starts. Data or any of the other things are there to help you. So I think the focus for everyone and has to be always to say, what is the business? Where do I need to be? Once you have established that is when you say, okay, now how can I accelerate this piece by using data, digital, any of those technologies, because those are all about improving it or transforming it. But knowing what business you are in, what the business context is, what are the financials or the commercials of that business are very, very critical. And then utilizing data and other things to make that happen, because that orientation will then also make you source the right data, focus on the right solutions. If your ROI on the business is only X, then your solution has to be frugal to justify that. You don't want to spend too much money on creating a data solution which is far more expensive than that. And many companies tend to do a lot of investments without necessarily thinking about ROI. So I would kind of end by saying that continue to focus on business, figuring out what is important. Having done that, then start to focus on what type of decision that you need to take to enhance your business. And from the decision making, you can then figure out what type of data will allow you to take that decision. And sometimes you don't need data real time. People are building some large system. Maybe your business is such that you can take decisions only on a weekly basis or a monthly basis. Then your system has to be designed to give you that data to take that decision at that frequency. Because if you get that information too fast, let's say you start looking at it daily, then you are likely to react to noise. And more importantly, you have probably spent a lot of money to get that data at such a fast frequency, which was not required. So I think we have to build to suit to what our business is. And every business has a different rhythm, a different cycle. And as long as we are coming from the business lens and then pulling in the analysis and data and making decisions, I think we'll be better off. So I would say that if you are a function owner, business owner, or whichever function that you are in, you have to figure out, what is the benefit that you can get by taking a certain decision, and that is the maximum you are willing to pay for a data solution. So if, let's say, you think that you need to take a decision, you're not sure, and the value of the decision is 100 rupees, your data solution or the data investment cannot be 200 rupees. And many a time we forget that, because in the enthusiasm to get the best system which has real-time data and all of those types of things, we tend to overspend. So I think be clear of what your goal is, how much you are willing to spend, and then go out and look for those types of solutions versus doing the other way around. So Anil, I'll stop here. I think maybe we will take up more questions as we go along, but that is what I wanted to share.
Yeah, thank you, Mr. Rai. I think there are some questions that are coming in, but maybe you could talk about a few examples of data science for maybe some sectors like the manufacturing sector or IT/ITES. Maybe one or two examples would be good to kind of conclude your session. So I'll just get back to you.
Yeah. In fact, there are some very interesting examples. One of the examples I still remember from my Dell days, which I still quote to many people. So we had two different teams. One was a marketing, sales, analytics team, and the one was the supply chain fulfillment team. And I'm sure Wilton and HP can relate to some of these things because it goes back to that industry. So I remember that Dell had come up with this idea that we will have laptops which will be colored. All of us grew up having these black or gray laptops, and someone, new leader came in and he said, we'll have colored laptops. And I think there was a pink or a red color or something that started selling very well, because maybe the, women were buying it, or I can't remember exactly, but it was just selling like hotcakes. So the sales and marketing team got very excited and they said, we'll promote it more, they'll give discount and sell more, all of that. Now, so the analytics team on the sales side was of course helping them find the right marketing brochure to make that happen. Now on the supply chain side, I think we ran out of red color, and there was a huge waiting list of that that thing. So the fulfillment was taking too long, and I think since both of those teams were sitting in one place in Bangalore, I think they were able to talk to each other and figure out that there's a disconnect, because usually what happens is sales and supply chain don't necessarily talk to each other very quickly. It takes a while for them to talk to each other. So it was it was a good case of cross collaboration across two functions through the analytics team, which was sitting next to each other, and discovered that one of the scorecard was hugely green and blue, the other scorecard was red, and they were two sides of the same coin, and they were able to sort of come together and fix it. So that was one example. I keep saying that you have to look at the big picture, that if something is green somewhere, hopefully there isn't something else which is lacking. Now, on the manufacturing side, there are some fantastic examples over here. So there is, in the world of manufacturing, there's something called a digital twin, which is really a simulation of that machine. So we have so many, different machines in our factories. So we look at some of the critical machines. Let's say, energy consumption is a big issue. So if we are able to simulate that machine using a digital twin, which is the key parameters of that machine, we are able to determine, at what parameter level the energy consumption will be low. and we can reduce energy consumption. So that digital twin is become a big important thing, because energy and green and sustainability is a big theme for us. The third one I'll talk about is this whole safety, because safety is very important in factories. So we have a lot of video analytics now. So earlier also these factories had cameras and they would monitor things, but now what we've done is, thanks to edge computing, all of these cameras and the algorithms are connected. So if we, let's say, deploy or learn something in one factory that this is a violation, then that same algorithm can be replicated and used by all other factories immediately, versus earlier when they were not connected. So there are, when you start thinking about what technology can do, there's enormous possibilities, and we are still discovering and learning. I spoke to you about manufacturing. There is in procurement, there is stuff happening. There is on the website, on the online. So there are several examples which we are trying to do, whether it is cross sell or customer service. There are techniques of natural language processing, where we are looking at call center data, determining what the customers are seeking, and then trying to make those happen. So Anil, I can go on and on, but yeah, this is a fascinating field. I think we are limited by our own imagination.
Yeah, thanks, Mr. Rai. I think I do have a question from the attendees, which basically is that nowadays data can actually come from so many different channels, right? It is RDBMS, or it is social media, or it is website, or it could be ERP. There are so many sources. The challenge is, how do you really identify what data to collect and what to really leave for drawing all the insights? What would be your advice on that?
Yeah, so like I said, that in my mind, it's the decision that needs to pull the data. So once you're sure that I need to take a decision on X, that what is the formula to take that decision, if I can say so mathematically. And therefore, whatever data is required is the only data that you should score. So that's the reason I am kind of very wary of these large data lake projects and all of that. Say, oh, we have so much data, let's bring it all in a data lake. Frankly, if 90% of the data is not usable because there is nothing that you can do using that data to take a decision, don't bring it on. So the term that I have coined is lean data analysis. And lean was a term used in manufacturing, where you would sort of reduce waste. So that's how I look at it, that a lot of data is probably waste. Only use the data which is relevant, and let's just pull that in.
Okay. Just one more question before we move to the next session. And again, people want to know. We talk about data, we talk about a lot of analytics and everything. But what's really the difference now between data science and analytics? Are they the same or are they different?
Yeah, so I think, as an industry, we keep inventing new buzzwords. In fact, I remember I used to utilize a terminology attributed to Michael Dell, who was the CEO of Dell when I used to work in Dell. And that used to be on my slide, which used to say, no one is interested in big data, but everyone is interested in big results. So I always used to focus people on the outcome and the result and the business value, and say, you call it big data, you call it small data, you call it analytics, you call it AI. Frankly, how does the customer or the user care? So I have kind of stayed away from determining what is the right buzzword or what should this be called. I say that the success measure is in the fruit of this thing and eating it. So the outcome is there. If you use mental math or a calculator, I think no one will come after you. But if you use the most sophisticated AI model where it didn't work, then I don't think anyone wants to talk about it. So I do think that people should not worry so much about whether what they are doing is called AI or ML or digital or data. I think if they can to focus their energy on the business and the outcome and the value, I think we will be much better off. I think there's too much time being spent on taxonomy, which I think is not very useful, at least from my perspective.
No, good. I think thanks for the valuable advice. Absolutely. One should be really focused on the outcome rather than just worrying about all the terms. We keep hearing so many terms that keep coming up all the time. Every day there's a new buzzword in the industry that keeps coming out. So good good advice. Thank you so much. So thanks, Mr. Rai, for all those insights and taking us through some of the journey that you and how you follow at Aditya Birla Group and everything, with some examples. So really great to hear those wonderful insights. For the attendees, I think that was about extracting business value from data by an expert who has been practicing it, who has created a team and who's done it. I hope you found it useful. We now move on to our next session, which is on basically why workstations are really essential for data science projects. If you really want to do data science and you want to be able to draw those insights and all that, you need workstations. And for which it's my really pleasure to welcome Wilton Pangoria, the category manager, mobile workstations, VR, data science and machine learning at HP Inc. India. Welcome, Wilton. Welcome to for this. It's great to have you. Wilton, before I hand it over to you, I'll just give a quick introduction about yourself to the attendees. Wilton has over 21 years of experience, out of which 10 years is with HP Workstations. He's currently responsible to drive new emerging technologies like data science and VR, and he's also responsible for workstation product management. Thank you, and over to you, Wilton.
Thank you so much, Anil. Thank you so much for this quick introduction, and thank you, Mr. Pankaj, for giving such a beautiful insight on data. So having said that, why do we require a workstation, or for that sake, any compute device for a data science? Because as we say, one side we have a data and another side we have a science, right? Now to mix the data with the science and to develop an insightful story, right? You require a compute device which is so much powerful that you don't have to worry about the number of rows or number of calculations you are doing per minute or per second. There are rows which are running like billions and billions of rows which you need to churn within on a per minute level, right? Whether it is a geoset data, or whether it is a mass population data, or whether it is a financial data, ultimately data is data which is growing leaps and bounds every minute as we are talking about. So to develop an insightful story from any data, we require a device which can do a compute, which can do a analysis for you, which is helpful in your day-to-day workflow, data science workflows, in terms of developing an algorithm, sanitizing the data and all that stuff. So let me quickly share my presentation, which is going to talk more on this front. Yeah, so as Anil mentioned, I manages the within HP as a product manager. I drive the new initiative or emerging technologies, which is data science and VR. So let's quickly talk about what is the future of data science with Z by HP. So what I'm going to talk about, the data science challenges and solutions, why we are talking from a Z advantage, what is we bring to the table for a data science workflows from a Z perspective, from a HP side, right? What are the data science softwares we've been propagating, and Z workstation configurations and evaluation program. So quickly, not taking much of time, the portfolio what we have on a desktop workstation front, we have got, if someone is into smaller kind of design, he can look for Z2 Mini and Z2 SFF, but specifically Z6 and Z8 designed for advanced visualization and data science. On a Z8 specifically, you can get 56 cores and up to 10,000 GPU cores. So not giving much of instance, because this is about the portfolio. Similarly, in mobile workstation, for specifically for data science, we have got something which is called a ZBook Fury. It's 17 and 15-inch form factor, which can give you up to 5,000 cores on a single machine. Now, what is HP's vision when it comes to data science? So we propagate, edge computing over a cloud computing by the nature of the industry what we are in. And during the presentation, we'll find out why we are propagating that. Accelerating, so Z by HP, Z workstations, we propagate accelerating data science workflows, complementing the enhanced and cloud infrastructure and fast acceleration of data science over edge. Now let's talk about the challenges what a day-to-day basis, or data science team is facing, and as a data science as the industry is facing over a period of time. Now, if you see, there is a graph which talks about the data, how it is growing. The numbers are in zettabytes. So in 2018 there are the data which has been populated is around 27 zettabyte, and industry overall is able to push 2 zettabytes over the cloud. No, so there is a gap of 25 zettabyte, which is not, which because of the bandwidth availability, the data scientists or industries are not able to push over the cloud. Similarly, if you see over a period of time from 19 to 20, this data is growing leaps and bounds, whereas the bandwidth availability is not growing in that fashion. So there is a limitation of bandwidth availability, and this is what forces to propagate that do the computing and analysis or data sanitization over the edge, not on the cloud. And there are different multiple challenges as well. Now there is a cost of energy which is growing on a monthly basis. Now if you see 5 kilowatt data, kilowatt hours, which is like 0.51 cent or 51 cents energy is costing you to push 1 GB of data, which is extrapolated. If you see in 2025, this is going to be 92 trillions. So this is how, this is what is, it is growing at a very fast pace, and that is where, the necessity of edge computing comes into picture. Now let's quickly talk about the challenges and the Z solutions or HP solutions, what we're talking about on a Z data science or on a data science workflows. Now, data science challenges first and the foremost is upload latency. Now, we all have faced, like, the reliability of bandwidth availability is not that great, and the amount of data we are playing, the amount of data from different sources, what we are getting, or the team is getting, there is always, a chances of, getting delayed, or there is a latency. Now, as data scientist has to be utmost careful while uploading a data, because it has to be accurate. Because of the latency or because of the low bandwidth availability, you cannot play with that. Now with the edge computing, with the edge device, the latency issue will be taken care of because it is available at your desk only. So we help in terms of reducing the latency issues. So these solutions allow to co-locate your, the workstations at your locations only. Bandwidth availability. Now, since it is at your desk, or on a LAN on your premises over the LAN, so bandwidth will not be an issue. Security and control, of course, there are third party or open cloud solutions which are available, but there is always the issue of, security and control. Many a times different departments wanted to have an access over the cloud, they have to, coordinate with different with IT departments to get an access, and it's always a tedious job. Whereas the similar amount of, compute power is available through workstation on their desk, so they, the control is better, and of course, since it is edge device and it is available at your desk, it is more secure. On cloud, we all know that is a accruing cost which is growing year over year, whereas on a edge device, you always have a fixed cost. You buy a workstation for once, it allows you to do, all kind of calculation for 5 years, and so on and so forth. Now when we say, Z data science, why we are saying that, why we are propagating edge, and why Z is, or as an HP, we are so excited about data science, and there are different advantages, what we propagate, what we bring to the table of data scientists. Now, single workstation will give you full throttle performance. It is Ubuntu certified, and Windows WSL2 is also certified. It can be preloaded, and this is world's most secure workstation. In Z8 kind of a machine, you can get 56 Intel cores and 10,000, GPU cores available on a single machine. GPU capability is far better. Now we all know the nature of compute available these days. One is through CPU processing, which is highly sequential in nature, and which is now no more suggested, and there are huge pipes which get built on this, which is not suggested for data science kind of an application. Along with NVIDIA, which is our partner in data science, we propagate a GPU computing, which immediately gives you more than 10,000 cores, and which is very parallel or highly parallel in nature. So your calculation or simulation, which typically takes over a week's time or maybe a month's time, can be done in hours or maybe days. Now we say that data science solutions, so it is so we propagate over the edge, over the cloud. We propagate edge calculations or edge devices. The breakthrough what we get is typically in 8 months. A data scientist can get the breakthrough versus cloud, because cloud, we all know that cloud costing is ever growing with the size of the data. And you can drive a $26,000 annual saving versus cloud. So there is a calculation behind that. Post this call, if someone wants, we can share that as well. Now, some of the big customers who are vouching, who can vouch for the data science solution what we have provided. So for example, NASA, over a period of one year, they developed solar eclipse and different type of images, which they takes typically more than a month to analyze. with Z data science, with Z workstations, they are able to do, that same calculation within a week, and the results are fast, accurate, far more accurate and faster. It is 100 times more faster than cloud, what they're propagating, what they're talking about. Similarly, American Airlines, for their logistic solutions, they have deployed Z data science solutions, and it helps them to reducing the time and more accuracy over on the data. Now, this is one of the big USPs what we bring to the table for data science workflows. Typically, we all know that once you buy a workstation or any device, it takes at least a week to fine tune that device for your needs, for your containers, your libraries, for your applications. But with Z, you will get everything preloaded, everything pre-tested, starting from Ubuntu 20.4. This is hardware tested, this is certified to run on these workstations. Similarly, if you see, there is a loss of productivity, loss of environment and loss of time as well when you wanted to fine tune your workstation for data science applications what you're going to use. So now these are the libraries or preloaded stack what we are talking about. This comes if you are opting for a Z data science solution from HP. So from libraries to programming language to developer tools to containers to GPU support tools, everything comes preloaded as a stack on data science solution workstations. So your time, the data scientists can be productive from day one. They don't have to muddle with their PC or with their device to load right set of applications or programming languages or developer tools. It saves a lot of time and bandwidth. And now we are in this business, a workstation business, from last 40 years, and we are propagating data science from last 5 years. We have done a lot of partnerships when it comes to data science, including Nvidia, Intel, and Microsoft. So these are the three big partners in this industry, wherein we are working very, very closely with these guys to develop futuristic solutions on data science. What they are bringing next in the industry for data scientists, we co-develop those solutions, applications, and hardware, and bring to the data science as a business. Now these are some suggested configurations what we have, what we propagate for data science workflows, depending upon what kind of application or what kind of usage the data scientists wanted to use. So Z Central 4R, this is a perfect choice for data wrangling, cleaning, and visualization. Now Z4, Z4, if you have got 4 to 5 billion rows, this is the right set of workstation, which is like Nvidia RTX A6000 GPU, which is 48 GB and can give you up to 5000 cores with 18 core CPU. Now, if you are looking for a complex simulation, machine learning, processing of large data sets, then we suggest to go for Z8, wherein if you wanted to run more than 5 billion rows, then this is the ideally suited desktop workstation which we suggest. Similarly, on a mobile form factor, these are the devices which are certified to run Windows and Linux and WSL2, and at the same time help in the workflow if you are a mobile data scientist. So ZBook Studio, ZBook Fury 15G8, and ZBook Fury 17G8 with RTX A4000 as an ideal suited workstations, mobile workstations for a data science workflows. Now these are the typical cards which is as per the industry standards are suited for any kind of data science application, with starting from RTX A4000, and we can populate up to RTX A6000 two numbers, so which gives you 10,000 cores immediately to your workstation. What are the key takeaways for this discussion? We propagate and we suggest to do a local compute, which to do a faster computation and sanitization of your data. You can confidently reiterate and develop models quickly and predictable at the predictable prices. So prices are fixed. Compatibility, so all these workstations are compatible with cloud environment and enables a seamless transition between your edge compute to the cloud and to your workflows. And we also provide from HP side, we also provide preloaded data science specific tools allows you to be a productive from day one. So And we also run a evaluation program. So if your organization, or if you wanted to evaluate a Z data science workstation for your workflow, for your data science applications, so you just have to sign up a form. You can contact me, right? We can provide you a demo machine to run, to train your workflow, to train your algorithm, and check the speed versus the cloud, and then probably we can have a discussion around that. So I'm skipping this. So these are my coordinates. If you wanted to know more details about Z data science workstations, or wanted to opt for an evaluation program, please contact me, drop me a mail, or call me. I will be more than happy to serve you on that. So that's all from my side. More than happy to answer, or more than happy to answer your queries. Thank you so much. Thank you so much for being a patient listener. Over to you, Anil. Thank you so much.
Yeah, thanks a lot, Wilton. I think great presentation. And, I see a lot of questions coming in while you were presenting. So I think it's now time for the Q&A. I will request, the studio to please bring Mr. Pankaj Rai also in the center so that we can have a joint Q&A. Wilton, I think, there's a question for you about, do you have any application for AR, VR mobile applications?
Yes, there are a lot of applications. So since this session is about data science, so I have not spoken about AR, VR. So as a complete workflow solution, starting from headset to the application, depending upon what industry you are in, I have an application ready for that. So you can contact me post this session.
Great, thanks a lot. Mr. Rai, there's a question there. There's an interesting question here, but I'm going to ask you the question a little differently. The question is about, it's a general question about, giving some brief insight on data science, AI, ML implementation. Obviously, that's a huge topic, but I think there is some amount of usage of data science and AI, ML at some of the, group companies of Aditya Birla. I heard that, especially in the steel manufacturing, Hindalco and all that, they've been using a lot of data for, that is coming out from all the machinery and all that. Maybe you want to, use that as an example to, explain how it's actually being used.
Yeah. So I think in this whole analytics, data science, all that, I think the reason some of these terminologies change is that there is some subtle evolution in some of these techniques. So I think when I used to be in Dell, we used to call our teams the analytics team, because you would do basic analysis and all that. I think those days AI was not very common. I think as more and more AI ML techniques started coming about, I think people started to call it data science. Now, I think what is starting to happen now is that data engineering, which is a step behind data science, is becoming more critical. So if you were to actually, go talk to people, people are finding hard to get these data engineering people. These are the people who kind of create the substrate, if I can say so, for data scientists to make those models. So in our company also, that is a big area, in which is where I think doing something one time is easy, but if you have to implement it, and there is if you were to go find ML ops people, which is machine learning operations people who know how to put these models in production, they are hard to find, because that is an area which is becoming very critical, which is the reason I think a lot of people are asking that question as well, and what's happening there and why, and so on and so forth. So I think especially in the manufacturing area, sourcing data is becoming very hard. And that was always hard in any area. I think in the past, you would talk to people and they say, I spend 70% time figuring out the data, only 20-30% time I am doing some analysis and all of that. Now, manufacturing has been very bespoke. I mean, if you look at manufacturing, there are different manufacturers. They have their own machines. Many a time that machine data is not made available in a very open source way. Many of those manufacturers have made their own digital practices to say, don't worry, we have our own practice. We will process the data and we'll give it to you. And many companies buy that and so on. So I think that area is becoming very critical, where we are using these factory automation. So I think in our case, there are two things which right now are going on, which is quite prominent in our group. One of them is the whole digital twin. So we have a copper business, and you spoke about Hindalco. This copper is also one of the businesses within Hindalco, which is a large aluminum company. Now, copper is very unique, and we are a major player over there. And there are not too many people doing work on copper. So our team is involved there in making a digital twin for the copper smelter. And there we work with the R&D team, because if you have to work on a manufacturing project, you have to also understand the material, the engineering behind it and all of that, because otherwise you will not be able to define that problem well. So there is a very unique partnership working with the R&D team who understand how the copper smelter works. Our people bring the data science team skill, and they are now evolving a digital twin for that copper smelter. And once that is made, I think it will have huge advantages in energy saving and just simulating everything and so on and so forth. So that's one big area where all of this ML will be applied more critically as the project comes to an end. But it's quite exciting, and there's a roadmap to get it implemented in another 3 months or so. The other one that I spoke to you about was the whole safety use case. So earlier we started off with all the video cameras and so on to look at earlier actually with the COVID. We said that we want to make sure people are wearing the mask, and you should flag off people who are not wearing masks. And then we said, why just stop at mask? Now in many places the same camera, you can deploy other algorithm, is used as a attendance tracking algorithm. It is also used whether people are wearing a helmet or not. Are they going into areas where they are not supposed to go? So suddenly, the whole area of all kinds of algorithms can be deployed using the same picture to say what all is going on when we started off. So I think that is where I was telling you that what we are creating is almost like a container or a marketplace, that all kind of algorithm made by any other startup or any other company can also be deployed on our same system. So we have developed this whole marketplace where you can bring in any startup. Let's say there's a fire hazard type of an algorithm that can be deployed very quickly. There's some other use case related to product quality that can be deployed quickly. So I think what we are trying to do is to accelerate the bringing in of other partners onto our system, because we don't think we should and we can do everything ourselves. So the idea we have created is to create a make and buy both, that we will make few things which are critical, but we'll buy a lot of different things on the market, and we have the opportunity to bring other things in as well. So those are some of the examples, Anil.
Yeah, thanks, Mr. Rai. Wilton, do we really need GPUs at workstation level also for data science? And if yes, what are the recommendations?
So yes, GPUs, gives you a immediate 10,000 CUDA code, 5,000, 10,000 CUDA codes, wherein on Intel codes, we have got that kind of a limitation. All the industries or all the, workflows on data science always recommend to go for a GPU compute, because they're highly sequential in nature. And it's a parallel processing, highly parallel in process, parallel in nature. So it's a parallel processing which helps you to turn out the result very, very fast as compared to the regular CPU compute. Suggested is like, depending upon what kind of data you wanted to sanitize or train, it entirely depends upon that. So let's say if you have got a problem statement which is like less than 1 million rows to be or less than 1 million rows to be calculated, you can go for RTX 4000, RTX A4000. But if you have got a problem statement which runs or a compute which you require a 5 to 7 billion per minute, then ideally suggested is RTX 8000, A6000 or RTX 8000.
Anil, I see another question on AR/VR use cases over there. So I can touch upon that also, because that is another area that is very critical. So the two use cases, or the two category of use cases that we find is training and troubleshooting. So we have some very expensive machines in our factory, which if not used properly, they can be damaged, or the operator can hurt himself and all that. So I think that is where we are using these AR/VR technologies. It's almost like you have these days car driving schools also have you go there and you have a simulator, or the pilots have their simulator. So so AR/VR technology is used over there, where you can, and I have sat in one of those those as well, where you can fully simulate including the bumps and everything, and you can learn that skill, and then when you go onto the floor and utilize that machine, then you are far more better off and all of that. Troubleshooting, and this troubleshooting actually use case came a lot more in the COVID time, when no one could be called. So if the machine was faulty, you couldn't do much. So I think some of it was learned thanks to the adversity that we had. In the past, people would say, "Bola lo engineer ko, aa jayega kahin se," all that. So now I think we have learned a lot about those troubleshooting. It's like almost the work from home and the stuff that we are doing now. In the past, we would all come together in a hotel and all that. So I think this troubleshooting has become a big use case, and a lot of other people are trying that. Why do you have to call the expensive engineer from Germany or US or wherever, if we can do it through AR/VR technology? So these two technologies, I would say, have a lot more potential. I think it is, like I said, limited by our own imagination and our own adoption and so forth.
So, Mr. Pankaj, just to add to this, like you have got a limitation in healthcare, wherein the cadavers are not available to do the the operations and all. So it is getting fastly deployed in that industry, wherein in hospitals, in sitting in your room or in a hostel, you can perform surgeries or you can learn how to surgeries. So this set of use cases are growing very fast.
Yes, Wilton. Thank you. Yeah.
Yeah, in fact, Wilton, another question for you is that since data scientists spend a long hours in front of workstations, so is there any kind of blue light filtering feature in these workstations?
So this is pertaining to screens. There are screens now available, and thanks to COVID, like there is a demand for this kind of screens. So there are screens which are available specifically designed for long hours. Wherein there are that cuts the blue light emitting from the LEDs. So you can check for this, or you can drop me a mail. I can provide you that information. And at the same time, but we also suggest regular 24-inch or 27-inch screen does not solve the purpose for data scientists. You actually require a larger size, maybe 43-inch curve monitors, because number of rows and columns are far more visible there.
Okay. And yeah, while you were giving a presentation, there was a specific question around edge specific and core specific laptops. How do they really differ?
Sorry, which specific? I didn't get you.
Edge specific.
Okay. So all the devices what is in front of me or in front of you on desk are all edge devices, whether it is a mobile, tablet, workstations, or any compute device which you are available in your premises is edge device, right? So today, with the thanks with the advent of technology, these devices are very, very powerful, right? So you can, as I said, on a single workstation, you can build up as big as like 10,000 cores in a single workstation. So all these devices are edge devices. All workstations are edge devices.
Okay. Well, thank you. I think that's all. I don't have any more questions coming in from the attendees. I think it's been a good round of questions that have come in from everyone. And, with that, we'll come to the end of today's session. I hope everyone found it useful. We'll be making this webinar available on demand. We'll also put up an announcement about the winners of the Amazon gift vouchers on the microsite where you registered for this session, and we'll also inform all the winners. Before you leave, I'd request you to fill up a feedback form to tell us how you found today's session. One is that, when you, leave the session, the feedback form will automatically pop up. The other is that there's a feedback form in the chat window in front of you. You could probably just click that and fill it up. Thanks once again. Hope you all have a great day. I hope you found it useful. Thanks for joining us in today. Have a happy weekend. Stay safe, stay healthy, and goodbye.
Thank you so much. Thanks, Mr. Pankaj.
Thank you, Anil. Thank you, Wilton. Thanks, everyone.
Thank you.
Bye-bye. Bye. Bye.